Hi, I'm member number 1 from group 4 and my name is Afidah binti Mohamed.
Hi, I'm member number 2 from group 4. My name is Wardina Batrisyia binti Nasrudin.
Hi, I am member number 3 from group 4. My name is Aina Syakirah binti Mohamed Hanif.
Hi, I am member number 4 from group 4. My name is Nuria Batrisyia binti Mohamed Zamree.
Assalamualaikum warahmatullahi wabarakatuh. I'm gonna solve the problem 1, maximizing crop yield. For the problem statement is a farmer in Malaysia used a new fertilizer to increase the yield of his crop. The yield Y in tons per hectare is modeled by this function, where X is the amount of fertilizer used in kilogram per hectare. So I will determine the amount of fertilizer that maximizes the yield. So the first step, we're gonna find the first derivative, which is the yield function given as so taking the first derivative, we got So the next step, we have to set the first derivative to 0 to find the critical points. By this equation, we have to divide it through by 6, and we got so next we have to factorize the quadratic equation, and we got x minus 2 x minus 3 equal to 0, and the critical points is x equal to 2 or x equal to 3. So the next step, we have to determine the second derivative, which is second derivative, which is we got 36. The answer 12x minus 13. So the next step, we have to evaluate the second derivative at the critical points. For x equal to 2, put the 2 in the equation, and we got 24 minus 13 and negative 6. Okay, since the final answer is lower than 0, so the function has a local maximum at x equal to 2, and for x equal to 3, we got 36 minus 13 and 6. Okay, since the final answer is bigger than 0, so the function has a local minimum at x equal to 3. So the conclusion is the yield is maximized when x equal to 2 kg of fertilizer per hectare. This is confirmed by the second derivative test, which show a local maximum at x equal to 2. The amount of fertilizer that maximize the amount is 2 kilogram per hectare. So that is the final answer. That's all. Thank you.
So the problem is minimizing pest control costs. So problem segment is the cost C in ringgit Malaysia per hectare of controlling pests in a maize field is given Cx equal x cubed minus 12x square plus 45x plus 20, where x is the number of pest control treatment applied. Determine the number of the treatment that minimize the cost. The equation is Cx equal x cubed minus 12 square x square plus 45x plus 20. So first, we need to change this equation by using derivative. Means first derivative. So the equation become c prime x equal 3x square minus 24x plus 45. Since the equation become a quadratic function, we can find the roots of this equation. Using equation, we cannot find value of roots that make exact value. After that, we the equation want to find the minimum of cost. That mean the minimum point. So we need to make the second derivative of this equation. That means c prime x equal 3x square minus 24x plus 45 become c second prime x equal 6x minus 24. Here is the second derivative equation that can make to find minimum point. Since the value of the root cannot find, therefore this equation doesn't have a minimum cost. That's all. Thank you.
So, the problem statement is this. The water used is W for irrigation. A soybean will be modeled by the function of P, where T is the irrigation time in hours. So, the question is, find the irrigation time that minimizes water usage. Okay, first step is find the first derivative. So, take back this question and put it here. So, this is the formula. Second, set the first derivative to 0 to find critical points. 200t minus 418 is equal to 0. So for t is equal to 480 divided by 200 to get 2.4 hours. indicator is determine the second derivative. So write the formula and put 200 t minus 418, get the 200. Next is size W is 2.4 equal 200 greater than 0. The function is concave up at t equal to 2.4, indicating a minimum. So the conclusion is the water usage is minimized when her irrigation time is 2.4 hours.
Next question is determining growth rate of a crop. Problem statement: the height h of a sugarcane plant over time is given by the function, this function. Okay. Where t is the time in weeks, determine the time at which the growth rate is maximized. So this question we need to know the time in weeks for the growth of a sugarcane plant maximize. Okay, now we're going to solve this. Step number 1, we need to find the first derivative. So we need to solve this number. Okay, so the answer is okay. Next, step number 2 is we need to set the first derivative to 0 to find critical point. Then we need to divide this by 50. Okay, next we need to factorize this number. The answer is t minus 2 and t minus 4. So, step number 3 is we need to determine the second derivative. This is the second derivative. We need to solve this. Then we need to solve this number. The answer is 30t minus 90. Next, step number 4, we need to evaluate the second derivative. This is the second derivative at critical point. So what we need to do is change the t to number 2 and number 4. Let me show you how to calculate this. Just change t and you can calculate and get the answer. Solve this and we will get 16 minus 19, and the answer is negative minus 13. Next, we're going to change t to number 4. And solve this. The answer is 120 minus 90. And the answer is, calculate, the answer is 30. So, the conclusion, between this calculation is the growth rate is maximized at T 2 weeks. So the answer is the growth rate is maximized at T 2 weeks. So that's how we found the time at which the growth rate is maximized by a sugarcane plant. Thank you.